Thank you for getting your review done. I have gone through and done each of the problems on your review for you. So once you have your review complete, go through this video, make sure that all of your review questions are correct. Circle any ones that you missed or that you don't understand and come to either class or math lab, and I will help you with how to do those correctly before you take your test. So use the following words to label the coordinate plane correctly: x-axis, y-axis, origin, quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay, so right here, this horizontal axis, this one is the x-axis. The vertical one is the y-axis. The place where the two intersect each other, that is called the origin. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Remember, as you are going through these, if there is something that you do not understand or need extra help with, circle that and then come to class or math lab and I will help you. Okay, so for this one, what is the ordered pair for each location of each point on the graph? So A is at -2, 3. B is to the right 3 and up 2. So that would be 3, 2. C is at 1, -1. D is to the right 3 and down 1. So that would be 3, -1. E is to the left 2 and down 4. Okay, so I'm going to write these a little bit bigger and better. So A was at -2, 3. B was at 3, 2. C was at 1, -1. D was at 3, -1. And E was at -2, -4. Okay, and I'm actually going to copy these because we need to use these for our next question. On question 3, it says answer the following questions about the relation in question 2. So this is a list of the ordered pairs for all of the points in the relation. Okay. A says, what is the domain? Okay, so remember that the domain is the set of all of the x values. Okay, so when we look at our ordered pairs here, remember ordered pairs are listed x first and then y. So we are going to list our domain, which is our x values, -2, 3, 1, 3, -2. Those are our x values. So if we list that as a set, it would be -2, 3, 1. We already listed the 3 and we already listed the -2. Okay, so this would be our domain. Domain is your x values. And then the second question, or question B, says what is the range? And the range is the set of your y values. So when we look at our ordered pairs here, 3, 2, -1, -1, -4, those are our y values. So if we list that as a set, that is our range, 3, 2, -1, -4. Okay, next question, is this relation a function? Yes or no? Okay, so in order for a relation to be a function, you cannot have any x values that have more than one y value. Okay, so we can see that we have an x value of 3 right here that has a y value of 2. We have 3 right here again, but it has a y value of -1. So 3 is being paired with both 2 and it's being paired with both -1. So this would not be a function. Okay, we also have -2 that's being paired with 3, and -2 is being paired with -4. Okay, this relation is not a function because there is the same x value that's being paired with different y values. The easiest way to decide whether a relation is a function is to look at your list of x values, and if they're all different, then you know that your relation is a function. If you have any that are the same, then your relation would not be a function. Okay. Now, you can have the same y value. So let's say we have 4, 6, 3, -2, and we have 1, 4, -2, 1. Okay. You can see that we have 1 listed more than once, but this is still a function because none of the x values are the same. None of these x values are paired with a different y value. Okay, so when you're deciding whether something is a function or not, the easiest thing to do is to look at your x values, and if none of them repeat, then you know that your relation is a function. If you have an x value that repeats, then you know that your relation is not a function. Okay, I did want to clear up some confusion. When you're deciding whether something is a function or not, it's okay if you have the same y value. When we look at this relation right here, we have 4, 1, 6, 4, 3, -2, -2, 1. None of these x values are the same, so this would be a function. Okay. When we're looking to determine whether something's a function or not, we don't worry about the y values. Okay. We're looking at the x values and we're looking to see if they are paired with more than one y value. Okay. So this is not a function because 3 is paired with -1 and 2, and -2 is paired with 3, and -2 is paired with 4. This is a function because every single x value is different. Okay, the next question says, what is the vertical line test? So I want to go back to the graph of our relation here. As we look at this graph of our relation, what a vertical line test is it's a test you can use to decide whether something's a function or not. So if something's a function, you can pass a vertical line through every point in the graph, and it will only ever touch one point at a time. Okay, we can see that when we try and pass a vertical line through this point right here, or through this spot on the graph right here, okay, can you see that this vertical line is touching more than one point at a time? So this relation failed the vertical line test. Okay, and we know, we just figured out that this relation is not a function. So if a relation is not a function, it's going to fail the vertical line test. That means that there will be at least one spot in the relation where you pass a vertical line through and it touches more than one point at a time. Okay, so like here's another spot where this relation fails the vertical line test. Okay, next set of questions. Circle the equations that are linear equations. Okay, so remember, linear equations can have just an x, they can have just a y, they can have an x and a y. Okay, neither variable can be raised to a power higher than 1. Okay? Okay, so the exponent of either the x or the y has to be just raised to the first power. And remember, when you're looking at a variable, if there is no exponent, that means it's raised to the first power. Okay, so if it's just an x, that would be x to the first power. If it's this, x to the second power, or y to the second power, or x to the third power, that would not be a linear equation. Okay, so in order to be a linear equation, the variables need to be raised to a power no higher than 1. Okay, also, if it's a linear equation, there's going to be no variable in the denominator of the fraction. Denominator. I spelled that totally wrong, you guys. Okay, there we go. So no variable in the denominator of the fraction. So this one is a linear equation, and this one is a linear equation. This one is not a linear equation because there's a variable in the denominator of a fraction. And this one is not a linear equation because this x has a power that's higher than 1. Okay, on question 5, it says write the two linear equations for number 4 in slope-intercept form. So we have 3 times x plus 4 times y equals 12. Okay, so we are going to write this linear equation in slope-intercept form. Remember, slope-intercept form is y equals mx plus b. So when an equation is in slope-intercept form, that means that we have isolated the y, and then we write it as the y equal to the x term plus the constant. Okay, and whatever is in the place of the m, that's our slope, that's the steepness of our line, and whatever is in place of the b, that is where our line crosses through the y-axis. That's our y-intercept. Now I'm going through this pretty quickly. This is just an answer video, and so if you need some help on any of these, please make sure that you circle them and visit me in class or in Math Lab or Miss Kohler. Either one of us can help you. We're both available. So now, to put this in slope-intercept form, we need to solve for the y. We need to get the y by itself. We can see that the y is right here on the left side of our equation. So in order to get that alone, we're going to need to subtract 3x from both sides, which gives us 4 times y equals 12 minus 3 times x. Then we need to divide by 4 on everything. So that gives us y equals 3 minus 3 divided by 4x. Okay, this is almost in slope-intercept form. We just need to switch these two around. Be careful when you switch them that you keep the negative sign in front of the negative 3/4 x. And then we'll have plus 3. Okay, so there is this equation written in slope-intercept form. Let's do the next one. Y minus 2 times by x minus 2 equals 6. So y minus 2 times by x minus 2 equals 6. If we want to put this into slope-intercept form, we need to solve for the y. Okay, our first step in solving for the y is to simplify the left side by distributing the negative 2 to both the terms inside the parenthesis. So that gives us negative 2x plus 4. And then from there, we're going to need to add 2x to both sides. So now we have y plus 4 equals 6 plus 2x. And then we need to subtract 4 from both sides. Make sure that as you are going through these, that you write down every step. Okay, show every step of your work. And then the last thing we need to do is to switch these two around. So y equals 2x plus 2. If you can do all of these questions on your review, then you will be able to do all of the questions on your test. Okay, question 6. Is the point negative 2, 5 on the line y equals negative 2 times x plus 1? Yes or no? Show your work to prove it. So we have this point negative 2, 5. We want to know if it's on this line. If a point is on a line, when you plug the x and the y of that point into the x and the y of the equation, it will make the equation true. That's how you know if the point is on the line. So we're going to take this equation, y equals negative 2x plus 1, and instead of the y, we're going to plug in 5. And instead of the x, we're going to plug in negative 2. And now we're going to see if this makes a true statement. So negative 2 times negative 2 is 4. 4 plus 1 is 5. 5 does equal 5. So we would say yes, this point is on the line. Okay, if you plug the point in and it does not make the equation true, then you would say no, the point is not on the line. Let's go ahead and try another one of these. We're going to take the equation y equals 4 times x minus 1. We want to know if this point is on this line. So we plug negative 3 in for the y. We plug 3 in for the x. So we're going to have negative 3 equals 4 times 3 minus 1. And now we figure out if this makes a true statement or not. 4 times 3 is 12. 12 minus 1 is 11. Negative 3 does not equal 11. So the answer is no. Okay? This point is not on the line because when we plugged the ordered pair in, it did not make the equation true. Okay, the next one, graph the following lines using a table of values. Remember the steps for this. Solve your equation for y and make the y a function of x. Create a table of values and choose some values for x to substitute into your equation and solve for y. Find at least 3 points that are on the line. So this sounds kind of tricky, but it's really, really easy. Our first step is to take our equation, negative 3x plus y equals 2, and we're going to solve for the y by adding 3x to both sides. So y equals 2 plus 3x. What that does for us is it puts it in function form basically, so that the y is going to be dependent on whatever the x is. So when we pick a value for x, we can simplify this and it will tell us what our y is. Okay, now we just pick any values we want to plug in for the x. I always use 0. Let's use 1 and negative 1. And you guys can actually use anything that you want. And then we take our equation here, okay, and we substitute these values that we picked for x into the equation, and then that's going to tell us what our y is when the x is that particular value. So 2 plus 3 times 0. 3 times 0 is 0. 0 plus 2 is 2. So when the x is 2, or when the x is 0, the y is 2. Let's do 1. So 2 plus 3 times, instead of the x this time we're plugging in 1. 3 times 1 is 3. 3 plus 2 is 5. When we plug in negative 1, 2 plus 3 times, instead of the 1 we're going to plug in negative 1. 3 times negative 1 is negative 3. Negative 3 plus 2 is negative 1. Now, this gives us some ordered pairs for points that are on this line. So now we're going to graph all 3 of these points, and that will help us to graph our line. So 0, 2, 1, 5, that means to the right 1 and up 5. 1, 2, 3, 4, 5. 1, 5, and then negative 1, negative 1. Okay? If you plot your points and they don't end up in a straight line, that means that you have done something incorrectly in finding the points. So make sure that as you do these, you are using a calculator and that you are doing your integer operations correctly. Okay, the next one, y minus 1 equals 2/3 x. So to solve for the y, we would add 1 to both sides. And now we're just going to pick some values of x to plug in. I'm going to go ahead and pick 0. This one needs a little bit more space, so I'm going to do it over here. Y equals 2/3 x plus 1. So I'm going to pick 0, I'm going to pick 3, and I'm going to pick -3 so that I don't end up with any fractions. So if we let the x be 0, 2/3 times 0 is 0. 0 plus 1 is 1. So when the x is 0, the y is 1. If we let the x be 3, so 2/3 times by 3. 2/3 times by 3 is 6/3, which is 2, and 2 plus 1 is 3. And you guys can use your calculators for these, okay? Please do. Please use your calculators to do your integer operations. The next one, 2/3 times by -3 plus 1. 2 times -3 is -6. 3 times 1 is 3. -6 divided by 3 is -2. -2 plus 1 is -1. Now, once we have our 3 points, we can plot those on the coordinate plane, and that will give us a graph of our line. So 0, 1, 3, 3, 1, 2, 3, 1, 2, 3. So the right 3 and up 3. And -3, -1. So to the left 3, 1, 2, 3, down 1. Okay, so there is our line. Okay, next question. Graph each line using the x and y intercepts. This is easiest to do if you put your equation in standard form. Remember to find the x-intercept. That's the place where the line crosses the x-axis at. You let the y-coordinate be 0 and you solve for the x. To find the y-intercept, you let the x-coordinate be 0 and you solve for the y. So this is really easy. We take our equation, -3x plus 2y equals 6. We let our y be 0. So -3x plus 2 times 0 equals 6. Oh, I'm going to run out of space here. Okay, so 2 times 0 is 0. So that wipes that out, which leaves us with -3 times x equals 6. We divide by -3 on both sides. 6 divided by -3 is -2. So our x-intercept is -2, 0. So if we go to the left, or to the left 2 and up or down 0, -2, 0, that's where the line crosses the x-axis. To find the y-intercept, this time we are going to let the x be 0 and solve for the y. So -3 times 0 plus 2 times y equals 6. -3 times 0, that cancels out. So we're left with 2 times y equals 6. When we divide by 2 on both sides, we get y equals 3. So when the x is 0, the y is 3. You can see that's the place where the line crosses the y-axis at. So there is the graph of our line. And we graphed using the x and y intercepts. Okay, y equals -2x minus 4. I am going to add 2x to both sides here. so that this is in standard form, because that makes it a lot easier to find the x and y intercepts. So now to find the x-intercept, we let the y be 0. Which you can see that leaves us with 2x equals -4. Divide by 2 on both sides. So x equals -2. So when our y is 0, our x is -2. Now let's go ahead and find the y-intercept by letting the x be 0 and solve for the y. So if we take our equation, 2x plus y equals -4, and this time if we let our x be 0, two times 0 is going to be 0. So we get y equals -4. So when our x is 0, our y is -4. So -2, 0, 0, -4. That is our x-intercept and our y-intercept, and we can use those to graph our line. Remember, as you are going through this video, this is just the answer video. Okay, so I'm going through the explanations really quickly. If there's something that you don't understand, please come to class or math lab. This video is not meant to teach you how to do this. That's what the lessons were for. Okay, this is just a practice for your test. This is just a review of everything that you've had a lesson on. Graph each using slope-intercept form. Okay, so remember, slope-intercept form is y equals mx plus b. So if we're going to graph using slope-intercept form, we need to solve for the y. We need to identify our x. We need to identify our slope and our y-intercept. Okay, so to solve for the y here, we would subtract 3x from both sides, which gives us -4 times y equals 8 minus 3 times x. Then we would divide everything by -4. I'm going to go ahead and write down here so I have a little bit more space. Y equals -2. 8 divided by -4 is -2. And then the -3 divided by -4 is going to be a positive 3/4. Okay, a negative divided by a negative ends up being a positive. Now, in order for this to be in slope-intercept form, I'm going to switch these two around and write it as y equals 3/4 times by x minus 2. So once your equation's in slope-intercept form, your first step is to plot your y-intercept. So that's the place where the line crosses the y-axis. From there, you use your slope, which in this case, our slope is 3/4, which means we're going to move up 3 to the right 4 from the y-intercept. Okay, so our y-intercept is -2. We move up 3, 1, 2, 3 to the right 4. And voila, there's our line. We graphed it using slope-intercept form. Okay, let's go ahead and do the next one. I'm going to clear this one off. 2y equals 5x minus 8. Remember, as you go through these, you are checking to see if you did these correctly on your review. If you didn't, you are going to circle them, and those are the ones that you know you need more help with. So y equals 5/2 times by x minus 4. This is now in slope-intercept form. So we know it crosses the y-axis at -4. 1, 2, 3, 4. And the slope is 5/2. That means we're going to move up 5 to the right 2. So up 5. 1, 2, 3, 4, 5 to the right 2. Next question, graph each inequality. Remember the special rules about your boundary line being dashed or solid, and then don't forget to shade the solution area. So to graph a linear inequality, you're going to put your equation in slope-intercept form. You graph using slope-intercept form, okay? But you have to remember, if your inequality symbol is just a greater than or just a less than, your line's going to be dashed. So when we graph this here using slope-intercept form, once it's in slope-intercept form, we know that it's going to cross the y-axis at 1. The slope is 2 over 1, so that would be up to the right 1. We need to make sure that we do a dashed line here. Okay, because our inequality symbol is just a greater than. It doesn't include, our solution area doesn't include the line. And then we would graph above, or shade above, sorry. Okay, if the y is greater than or equal to, you shade above. If the y is less than or equal to, you shade below. Okay, next one, we are going to divide everything by -2. Remember, when you're solving an inequality and you divide by a negative, you have to flip the inequality symbol. Okay, so to graph this one, we know it crosses the y-axis at -2. We know the slope is down 3 to the right 1. This time our line is going to be solid. Okay, so that means our solution area includes the line. So that means we could pick points on the line that would make this inequality statement true. And then our shading needs to be below the line because the y is less than. Okay, so remember this area that we shaded in, this is our solution area, and that solution area also includes this line. So that means that we could pick a point anywhere in this area or on the line, and they would all make this inequality statement true. If we look at this first one, we can pick a point anywhere in this shaded area, and that would make this inequality statement true. We cannot pick points that are on this line. Okay, that's not included in our solution area. Okay, 12, 13, 14, we're almost done here, you guys. Write an equation for a line that has a slope of 3/4 and a y-intercept of -5. Remember, the way that you know which writing equation form you're going to use is the name of the form tells you what you need. So if you're going to write an equation and you're going to use slope-intercept form, that means that you need to be given the slope and the y-intercept. If you're going to write an equation and you've been given the point that the line crosses through and a slope, you're going to use point slope form. Okay, so it's all dependent on what you've been given. Remember, point slope form is y minus the y from your point is equal to m times by x minus the x from your point. And sometimes you may be given 2 points, and if you're given 2 points, you can graph using, you can write your equation using point slope, because if you have 2 points, you can find slope by finding the change in y over the change in x. Okay, so let's go back to these 3 questions. Write an equation for a line that has a slope of 3/4 and a y-intercept of -5. So since you've been given a slope and a y-intercept, you're going to use slope-intercept form. And all you do is plug the slope in for the slope and the y-intercept in for the y-intercept, and that gives you the equation of your line. So y equals 3/4 x minus 5. Those are the easiest ones. Okay, 13 says write an equation of a line in slope-intercept form. Okay, so in the end, we're going to have to put our equation in slope-intercept form that passes through the point -2, -1 and has a slope of 1. Okay, so before we can do this part, we actually need to write our equation. And we're going to write our equation using point slope because we have been given a point and the slope. So this is our x, this is our y. Point slope is y minus the y from our point is equal to the slope times by x minus the x from our point. Okay, so y minus -1 equals m, which is -1, times by x minus -2. Now from there, we need to take this equation and put it into slope-intercept form. So we're going to distribute the 1 to both of these terms. So -1x minus 2. Okay, and then we are going to subtract 1 from both sides. And now our equation is in slope-intercept form. Okay, let's go ahead and do the last one. Okay, so this last one says, write an equation of a line in slope-intercept form that passes through the points 5, 4, and 7, 2. Okay, so in the end, we're going to put our equation in slope-intercept form. But before we do that, we need to actually write our equation. And this time, we've been given 2 points. Okay, so because we've been given 2 points, we are going to first find the slope of the line that passes between those 2 points. So we have 5, 4, and we have 7, 2. Okay, so if we want to find the slope of the line that passes between those 2 points, we're going to use the slope formula that says slope is equal to the y from the second point minus the y from the first over the x from the second point minus the x from the first. Remember, when you are using the slope formula, the most important thing is starting out by labeling your points. So this is the x coordinate of the first point. This is the y coordinate of the first point. This is the x coordinate of the second point, the y coordinate of the second point. Now, once we've done that, it's very easy to plug in to our formula. So instead of the y2, we're going to plug in 2. So 2 minus y1, which is 4, over x2, which is 7, minus x1, which is 5. And we know that 2 minus 4 is -2, and 7 minus 5 is +2, and -2 over +2 would give us a -1. Okay, so our slope is -1. Let's clear all of this out now. So once we know that our slope is -1, now we're going to pick one of these points and we're going to write an equation using point slope. So here is the x, here is the y. Y minus the y from our point, which is 4, is equal to m, which is -1, times x minus the x from the point, which is 5. So now we would distribute the -1 here and here. So -1x plus 5. And then we would add 4. So y equals -1x plus 9. Okay, so let's go ahead and look at the last 2 questions. Remember, this is just an answer video, so this is not meant to teach you how to do this. If you don't have any idea how to do these and this is super confusing, you need to make sure that you come to class or come to Math Lab so that we can help you so that you're ready for your test. Okay, and also make sure that you've done all of the lessons first too. That's where you actually learn how to do all of this. So on the following graphs, distance as labeled on the y-axis refers to the distance from an amusement park. Which graph best matches the following sentence? Hugo walked at a steady pace towards the amusement park. So even though this looks like someone's walking at a steady pace, when we pay attention to what is being graphed, which is time over distance, this actually shows a person standing still, not moving forward at all. Time is passing, but they're not moving. Okay, so it wouldn't be this graph. This one shows them if this is the amusement park here, this is showing a person walking back towards home from the amusement park. This one right here shows a person walking at a steady rate towards the amusement park. Okay, so it would be C. This one shows someone walking from the amusement park back home and then walking back towards the amusement park again. Okay, 16, write a story that matches this graph and give the details of what is happening at each location. As you look at this graph, this is time and this is distance. An idea for a story that I thought of was a kid is playing at a friend's house, and then he decides to go back home and to eat lunch, and then to go back to his friend's house after lunch, and then to go back home a little later in the day. Okay, you can come up with whatever story you want. Just make sure that your story matches the graph. Okay, wow, that was really long. I hope you stayed with me. If you missed any of these on your review, or if there were any that you didn't understand, please, please, please come to class or come to Math Lab so that Miss Kohler and I can help you. We want you to do really well on your test. Remember, your grade comes from your test, so you have to be able to do each of these things to be able to do well on your test. So with that said, hope you guys have an awesome day, and I will see you soon. Good luck on your test.